Hello. Well, recently we've been working on this Grundig, extremely rare machine, especially rare in the UK, that takes these tapes, which is a variant of an earlier Philips N1500 and N1700 format. Has a little bit of extra plastic in here that tells the machine that this tape can record for a longer time, up to 4 hours on these tapes. So it's the SVR4004, obscure machine, only one model made of this format. I repaired one of these machines, and the second one I made a huge amount of progress. I got the machine running about a week ago, and it lasted for about a minute and then broke down. So most likely a tantalum capacitor has gone short circuit somewhere and is taking out one of the power supplies. Let's work on this. So if you watch my previous video, you will see that I'd got the position that most of the machines seemed to work. The clock and everything was all working, and I was able to press play, fast forward and rewind. This machine does not yet have audio video ports, so I was plugging in the aerial cable into the modulator, and before I got a chance to do that, the machine broke down. It will do nothing apart from when you press the function buttons, the head spins up. Let's confirm that's still the case. So we power up, the clock display is flashing. If I press play, oh, it's working! And then it unlaced. Well, it worked for a moment. That's interesting. Let's see if it does anything now. Ah, now it's back to that fault again. Interesting. So maybe it's not a short circuit tantalum capacitor, because if it had gone short circuit, it would have stayed short circuit. The machine actually seemed to run for a second then. Interesting. But we will start on the power supply and check that the rails are where they should be. First thing I'll check is I've left a wire on here which is pin 7 of the relay. It's the 15VR line, which should be operating when the relay clicks on, and I think the relay may not be clicking on. So let's just check that. Oh, and I've also been told by a viewer, that when we had smoke the other day from the power supply, that shouldn't happen, and it implies a possible safety issue, because the SCR should be triggered so that we can't smoke out if there's a fault condition. So we will have to look at that again in the future. I will probably replace the regulator IC, the UA723, with a higher quality component, because I'm not sure of the heritage of the one that's in there. But right now, let's just try and get things going. So, do we have 15 volts on the line that should trigger, should be operated when a function key is on? Well, we have 15 volts, but only if I hold the button on. Let's check our other power supplies as far as we can get to them. Some of them are very difficult to get to. And you'll remember also that I've criticised this machine a lot because there's mistakes in the service manual. In particular, some of the connectors are marked the wrong way around. So we have to be a little bit careful. Okay, so this is our B4 connector at the top here. Pin 1 is at this end, unlike what it says in the service manual. And we'll run along and just measure the voltages. So we should have minus 26 volts on the first one. About minus 30, but okay. Pin 2 is ground. Pin 3 is not used apparently. Pin 4 says to motor. Pin 13. Pin 5 is the pin. Pin 6 goes to the clock. I think it's timing signal of the clock. 7 should be plus 12 volts. D it says. Got 12 volts, slightly over. Pin 8 goes to the logic board, I think. It doesn't tell us what it is though. 9 goes to the IF module, I think. 10 is not used, it says. Though it's actually 5 volts. We're going to have to pull the power supply out a bit so that we can look at B1, which is at the bottom there. Okay, looking at pin 1 of B1. So we're looking at 36 volts there, I think. Let's try that. Yes. About 33 I'm reading. Looking at B1 now, which is down here on the PCB, and is again numbered the wrong way around on at least part of the schematics. So pin 1 is on the PCB end. That should be about plus 36 volts. Let's just check that. About 33, close enough. Pin 2 is W15 volt, which is Wiedergabe, which is play. So I think this will probably go into play, into 15 volt when I press a button like play. Actually, any button is making that do it, but it's not latching into play mode and it's not lacing up. So that's all wrong. Pin 3 is plus 15 VR, which is when the relay is on. We tested that just now, and I think that's going to do the same, isn't it? We're going to get operation when I press the button, even press the stop button. Pin 4 is plus a 15 volts, which is Aufnahme, record. I'm not even going to bother. Well, I suppose I could test it. So if I press, say, any old button like stop, nothing happens. If I press record, well, no, it's still not going there. Then we have 2 grounds. Then Aufnahme information. I don't know what that means. Something to do with record information. It's like a record signal, I suppose. Then we've got the pin lock, which is actually broken off on this because the connector's broken. Then we've got plus 26 volts we should have on pin 9. When I press the button, it's going to 26 volts. And finally, plus 15 D, which is always on when the power switch is in the off position. So when I switch it off, I get 15 volts. When I switch it on, it stays 15 volts, interestingly. I don't know what to make of that. I don't know why that's always 15 volts. Because according to the instructions, that should be 15 volts, if I've read it right, only when the power switch is off, and it's staying at 15 volts at all times. So we have a great deal of weird stuff going on, but what I'm not seeing is any dead shorts. So this is going to be a bit tricky to debug, isn't it? I'm just going to momentarily go back to B4, which is one at the top, because I think there's an extremely important signal here. On B4.8, let's start from the edge, 1, 2, 3, 4, 5... That's the can lock 6, 7, 8. This is a signal which comes from the syscon panel, ablaufsteuerung, and tells the relay to switch on. So let's just look at that. So the machine's in the on position at the moment here. If I press play, it goes to 5 volts and switches the relay on. I can hear the relay as well. But it's not latching on. And the machine's not lacing, though it did lace the other day and it started lacing just now. So I think we need to be looking around the ablaufsteuerung board, which is the syscon. It's as though it's perhaps getting a wrong signal somewhere, and so it's not allowing the machine to lace up. So I think I'll put the power supply back for a minute and let's go to the bottom of the board, the main board, and look at some signals around there. Just one thing I wanted to rule out before we start is whether it thinks there's no tape in there. This light here is supposed to come on when there's no tape, so I eject it and that light does indeed come on. You know, I knew I'd seen this behaviour before. Let's go and look at our good working machine and put into it a VCR or VCR-LP tape, which doesn't have that small plastic tab in it, which indicates that it's suitable for SVR use. And when you put that in, the red light lights up, which says it doesn't have a suitable cassette in it. But interestingly, the way the machine then behaves is just as we're seeing now, that you press one of the buttons, its function light comes on, the head drum spins, but it doesn't lace up. Now returning to our defective machine, it's behaving exactly the same way, except that the red light is not on here. But we're getting the same behaviour here. In fact, if I put this VCR tape in, the red light comes on and it will behave exactly like a fully working machine now. So that's got to be a big clue as to what's wrong here. That it's behaving, apart from the red light, exactly like you've put one of the earlier non-SVR type compatible cassettes in here. Now, because the red light's not coming on to sets missing or unsuitable cassette, that eliminates the switch, which detects that small extra piece of plastic. But it kind of feels like it's the logic that is making it think that it doesn't have a suitable cassette in there. Maybe. There's a cassette, well, carriage down loaded switch here. And I'm not absolutely convinced that that's working properly. I've tried to meter it and I got extremely inconclusive readings from it. So I'm going to clean that switch. Right, let's point out all the switches, and I've cleaned them all. So there's this one here for the cassette in. There's these 4, I think there are, detect the position of the loading ring. I've cleaned all of those. Plus I've cleaned anyway the switch in here, which detects if you have that piece of plastic that makes it a VCR SV super video cassette recording rather than a VCR cassette. We know that's working because the red light goes out here when we put the correct kind of tape in. I've cleaned it anyway. So that's all the switches that I can think of that could be responsible for the problem. This is not a switch. This measures back tension and applies reverse bias to the supply spool based on how much back tension it measures. Similar to the SLC9 and most V2000 video format recorders. One thing I have noticed is, remember we had a bit of trouble with the light bulb? It seems to be coming loose, and maybe that's not helping our cause. So let's see if we can secure the light bulb a bit better, because if that's not shining properly through the cassette, that could cause us problems, couldn't it? I'll just pop it back in place for a moment and see if the problem goes away, and if it does, then I'll know that that's where I need to focus my attention. No. But nonetheless, we need to secure that light bulb. It seems to be sort of held on with a bit of glue or something. So yes, I'll use a replacement bit of glue on that. So we're still looking at some kind of logic fault, some kind of reason that it's refusing to lace up. I wonder what the other reasons can be, apart from an incorrect tape type, that would make it refuse to lace up. Or indeed no tape in there at all. Because the machines will do what we've described with no tape in there. They will do exactly that when there's no tape. You know, it really wasn't my plan to do any part swapping with the other machine, because that works. But I think I might make one exception. The syscon board, I think, is fairly easy to swap out. So this is the top connector for it. Right, I've decided to borrow the ablaufsteuerung board, which is the flow control board, or in other words syscon, from the good working machine. It's a little bit tricky to take out because the connector at the bottom is also held in with this plastic spigot which plugs into the bottom board, and the only way to sort of squeeze these properly is from the underneath, so you have to take the bottom off. But okay, so that's the known good one. So we'll whip the board out of here. So I've got to release that clip, which, as I say, you've got to kind of squeeze from the underneath and push like that. Okay, so this is our suspect one. I really don't think this is the cause of our problems, but As it's relatively quick to swap over, we'll do that. But if it doesn't fix it, I'll put this one back, since there's always a possibility of different firmware on them. Right, so for a moment I won't refit that, since we're just testing it. Okay, let's test it. So the important thing is that red light has gone out, so it is the correct type of tape. And what happens? It worked! I wasn't expecting that. I really didn't expect it to be a problem with the syscon board. And it might yet not be, because the problem may come back. But let's see if before the problem manages to come back, we can plug this in with the modulator and test it. It's a nuisance there's no AV output yet. Well, that's a surprise. So what are we seeing? A black and white picture. It has got sound. And it looks like the speed may be wrong. If I hit stop, we get something resembling a black and white freeze frame. I think it's running slow. On the plus side, the drum servo looks like it's working because the picture is recognisable. Oh. Now we have colour, but really the tracking's not working. Or is it doing something? Oh, the tracking's doing something. So, given that the tracking's never that good on this format, that may not be a fault. The interoperability between machines is not given on this format. So we have some mistracking. The tracking control is working. It is running at the right speed. It sounds a little unstable. I don't know if you can hear that. It just sounds like something's hunting slightly. And the thing is, that noise is coinciding with the mistracking at the bottom of the picture. I don't know if you can hear that. Let's hit stop. Right. Very close to working. I'd like to try another tape, I think. But the other thing I need to do is try the flow control or syscon board from here that we had the problem with on the other machine. I'll also in a moment just check the ESR of those two capacitors. Yeah, let's try this on the other machine in a moment. I'll report back. So when I tried this suspect board on the known good machine, it behaved just like this one was, with no operation from the buttons. So we have a fault on this board. That's a surprise. I didn't expect such a simple board, syscon board, to have a fault on it. So we'll work on that in a moment. I'm going to refit this back to the other machine and confirm that's in good working order again. Right, a quick check of the two capacitors, two electrolytics on here. I really doubt these are the problem. So what have we got here? A 10 microfarad. Did I mention I've got remote control on this thing? That's reading 14 and a good ESR value. I know it's in circuit, it's not ideal testing in circuit. And the other one's supposed to be 22 microfarads, and that's reading 24 and a bit. So the capacitors are not the problem, but something in there is. This is interesting. I'm going to say that whichever bit of circuitry that operates this LED here that says do not use this cassette, I'm thinking that bit of circuitry is where I should be looking. But before I do that, I'll just refit it to the machine and confirm once more that the fault still exists, and it's nothing to do with having just moved things around. Now of course, debugging this would be so much easier if I had the extension cards that would allow me to bring this out and work on it, but of course I don't have such things. Faults there. Well, this is fascinating, isn't it? What we don't want it to be is the chip, because if it is that, we're done for. We'll never get another one of those. So let's hope it's something else. If the chip had failed, I wouldn't expect it to even try to work. The way it's behaving is not as though the chip has completely failed, I believe, though it could be a bad input. Right, let's look at the service manual. I've been trying to work out what pin does what on this board, and unfortunately there's lots of very vague pin names which don't translate terribly well to English. So I just can't work out, loads of them are labelled cassette and pin and things like that. It's just not very helpful. But I've got a sneaking suspicion pin 24 is what we're looking for. It says pin or shaft, and it goes off to a couple of places, and it's got a capacitor on it, I think. So I've been trying to make some sense of the various pin names here for the signals that go into this. It seems by and large that mostly signals go in at the bottom, out at the top, but the way they've done it is the ones that have got a socket marking on the schematic are at the bottom, and the ones that got a pin are at the top. That's fine. And since I can't really make much sense, they don't translate very well, lots of things are rather vaguely labelled cassette and things. What I'm going to do is get ourselves to the position that I can, what I'll do is I'll put a tape in that's not suitable. So I'll put in a 1700 tape, and then I'll actuate the micro switch here so that it goes in and out of flashing this light, and look for that signal mainly on the bottom. It might appear at the top, but mainly I think it's going to be on the bottom. And if I can find it, then I then know which pin has the signal that is of interest, and maybe we can find if there's a problem with the component on the board. So it's the only way I can do it, because translating it just isn't really giving me the information I need. Right, so here's the offending micro switch, which detects if you have an SVC tape in there. Because it's behaving like that's not working, let's find that signal on the input to this board. And what should happen is when I operate this micro switch here, we should see this light go out when I push it down. So let's just prove that first. Yep, good. So now I need to do the same thing with the machine on its back, looking at the pins at the bottom. So there's a lot to try to do at once. I could really use a hand here. Okay, the machine is powered up. So here is the bottom of that board. Pin 1 is over here, and I'll operate this switch. You can hear me operating a switch, and I'm looking for one of these pins to change state when I operate that switch. And some of them are shared with this connector, which is just extra specially unhelpful. I'll just go along this connector, I think. That's it. Goes to 0 and up to 8.5 volts as I let go of the switch. That's on the red wire on the lower on that connector. Okay, we've detected where that switch is. So that will presumably be the pin on the board where the signal is going in and it's not being processed properly. So I need to work out which pin that is that's on that red wire. Well, that didn't work out because pin 26 is ausfädeln. My German's not that good enough, but it translates to thread out, so that is not one of the cassette switches for sure. But nonetheless, we were seeing on that pin a change in voltage when I was activating this micro switch for the tape type. Doesn't make much sense, that, does it? We're going to have to, I think, look at where that micro switch goes and follow the wiring through. That might be a better way to do it. Right, I've metered that red wire through to the micro switch. That is definitely our pin, but it's not on pin 24, it's on 22. So that is our switch which is not being looked at properly. Pin 22, according to the diagram, sensor, cassette sensor. Bit vague, but I think that's it. That's our switch. So pin 22, where it goes onto the board, that microcontroller board, one of two things. Either there's a problem with the microcontroller board, or the voltage on that switch is marginal and it's been picked up sometimes by one of the processors and not the other. So we need to look at what the proper voltage is for that pin, and if that's correct, then go through the board and see what components are on it. Right, and the instructions say that pin 22 should go between grounded and 8.5 volts, and we are getting 8.5 volts. So the voltage is correct, therefore the fault is apparently on the microprocessor board, the syscon board, and we just need to follow what components there are. Well, it can't be an overload on the output on pin 6 on the top, because if there was a problem there we would get the wrong voltage. So what have we got? There's not many components there. Well, that got us absolutely nowhere, because what's going on here, this is the input signal here on pin 22 of this connector, and it just goes to pull-up resistor up to 15 volts and then back out to the top connector with this signal, and that signal, well, it gets renamed for no particular reason, but that signal then appears at the LED driver for the front panel. Well, we know that works, so I'm wondering if we should be looking at the other side of the switch, because this switch I've been on about that detects the cassette type, this one here, is a changeover. We've been on the red wire on the top of this micro switch here, but there's a yellow and white wire that snake off into the distance somewhere, and presumably it's one of those which instructs the microprocessor to not function when it's got the wrong kind of cassette in it. So I don't know which pin is which on this changeover switch, but I can meter it out, find out, and then one of them be common with red, and we know that works, so it's the other wire that we need to trace. I think it's the white wire here, which is the other side of the switch. So I believe the yellow wire in the middle is common, and the white wire is normally closed, and the red wire is normally open. We know the red wire is working. Got to trace that white wire through. Okay, I'm on the white connector here on the cable that goes to the logic board. I call it loads of different things, don't I? Syscon. We'll call it Syscon. And we'll connect now to the... We've got a real SVC tape in here, and connecting to the bottom of that switch. There it is. So, well, that's pin 24, I think, and earlier on we looked at pin 24 and it wasn't relevant. It was something to do with unlace. But no, it really does appear to be the other side of the switch. It's a changeover switch, and I think the center pin is ground. But no, there it is, that white wire, which is pin 24, is the other side of the switch. So we must assume that that is the signal that's telling the microprocessor, the syscon board, that the correct type of cassette is or isn't loaded. So going back to having the wrong type of cassette in there, I will meter the voltage on what we now think is the correct pin when I actuate that switch there. So we're on the white wire, wrong kind of cassette inserted, activate the switch, and it does indeed go up, but not by very much, only a fraction of a volt. Okay, let's look at the specifications for that one. Well, according to the schematic, that should be up to 15 volts, and we were only seeing a fraction of a volt there. So we may have a component failure somewhere on that pin 24 input. I need to be looking, I think there's a capacitor, a transistor. Well, the transistor's on the other end of a 100k resistor, so that's not the problem. So let's have a look at C1189. Don't see any of the other components there that could take us down to approaching 0 volts. Even if the input of the IC was defective, I don't think it would go that low because the input resistance is 6.8k, although I'm not quite sure what would be pulling it up. Yeah, let's have a look at the that capacitor anyway. We think our problem is associated with pin 24 here, so we're looking for something pulling the that signal low. So from pin 24 to ground, I'm seeing 1k. That's now called shaft contact, which is something like shaft contact or maybe pin contact for this sensor. So that's quite a low pull down, and that might be our fault. If I still had the other board to hand, if I hadn't refitted it to the machine, I could look at that one, but I don't want to do that right now. Well, you shouldn't have anything there pulling 1k to ground, should we? We've only got 100k, a capacitor, and 6.8k. There should be nothing like 1k. What capacitor is that? C1189. So between this point here, which is our signal interest, we should see a 100k ohm resistor, which is that one, and a 6.8k. Okay, neither of those will give you a 1k leak to ground. So where's it coming from? Well, there is this capacitor here, C1189. Are we getting the 1k leak to ground across that? Yes, we're getting a 1k leakage to ground across that capacitor. And I don't see any other paths to ground. So it looks like that capacitor's gone leaky. Is that possible? Fairly unlikely, but let's test it. Of course, when I heat it up with the soldering iron, it's very likely to change whatever reading it gives us, but there's no way in the world I can see how we can get 1k to ground unless there's some leakage path somewhere else along here that I haven't seen and isn't on the schematic. Right, I've desoldered one end, so we'll either have 1k still there, in which case there's some other path, or it's just the 1k on the capacitor. So let's look on the path. That's now megohms, and on the capacitor, 1k. Let's take the capacitor out. It says 100ns, which is a, not sure what the S means, because that might imply 100 nanosiemens, which is a resistor, but no, I don't think so. Now it's behaving like a capacitor. But I did say desoldering it might change things. Do we still have 1k to ground there? No, it's megohms. So let's fit a new capacitor. Right, the schematic says it's a 0.1 microfarad, 100 nanofarad, and we have a 100 nanofarad capacitor there. I'll just try to measure the capacitance of the one I've taken out. It might read okay now. Yeah, it reads reasonably well okay now, but I'm not going to put that one back. So I'll fit that one. Let's refit this and see if we've been barking up the wrong tree or if it now works. Right, we need to refit, of course, a real SVC cassette because that one wouldn't work. And let's just see if it runs. We haven't yet refitted the mount on the front of the board. There's lots of other things to do, but let's just see if it now goes into play. and fast forward, stop and fast forward, and with a scraping noise for some reason. But that was it. One leaky capacitor brought the machine down. You know, the picture on this machine really isn't looking too bad at all. There's a nice feature on this machine as well I want to show you. You get this on professional equipment like Betacam and some pneumatic machines, where you get the tracking control and a meter to show you how good the RF signal is coming from the heads. Never seen that on any other domestic video recorder. Right, there's still plenty more to do. I've got to fit a video output system. We want to look at the tracking, see if that's okay. The tape counter won't reset. So there's a few odds and ends still to fix, but fundamentally we're starting to make progress. Now, sometimes I've had a few detractors, you know. People who've said, oh, you don't have a clue, you should have fixed that in no time. Well, there we go. I found that component, which was leaky, using just logic and the schematics, which are badly written, full of mistakes, and in German, and unclear. So, to those detractors, try to detract from this. Come on, tell me what I did wrong and how I should have done this better. Anyhow, I'll be doing plenty more content on audio and video technology in the near future. I've got some interesting things coming up. This may not be next week's video. Perhaps we'll take a break while we wrap up a few things on this one and do some different stuff next week. See you soon. Bye. Let's test this capacitor on the power supply and see if we can get it to leak again, because it was reading about 1 kilo ohm when it was faulty, but of course desoldering it may have fixed it. So putting it on a bench power supply, if it starts to conduct, we should be able to see some current flow here. No, it looks like desoldering it solved its fault, but nonetheless it was definitely defective at the time. Channel supporters on Patreon will have seen an extra video I did this week where I had a 0.1 microfarad capacitor fail in another piece of equipment. It's a big expensive digital time-based corrector, and in that case it went short, took out a power supply, created smoke and horrible smell, and I was able to locate the capacitor just by looking for it. So do consider being a patron and get to see extra videos like that.